going to start out with denary or decimal numbers. You can think of this as a base 10 number system. We probably developed this because we have 10 fingers on our hands, so we're used to counting by 10. The place values are ones, tenths, hundredths, thousandths. You could think of it as 10 to the first power, then 10 to the second power, and 10 to the third power, and it would continue going up like that into the further place values. And if you're counting, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10th digit would come over to the tens place, and the digits in the ones place you'd have a 0 in the ones place there, and that would be 10. And then continue going, 11, 12, 13, 14, 15, 16, 17, 18, 19. When you get to 19, then you'd get 2 digits in the tenths place, and it would continue on 0, 1, 2, 3, 4, the way we're used to counting. And it would continue going up using that base 10 number system. Okay. The next one we looked at was binary, and this is going to be slightly different. And when I'm counting with binary, I'm just going to be using the ones and the zeros. I think it makes a little bit more sense. But again, you see the place values down there, 1, 2, and you can think of this as 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, and 2 to the seventh power. I did 8 place values just because we're used to working with bytes or 8 binary digits. So counting with binary, we will have a 1, and then this 1 will become a 0, and we'll have a 1 in the 2's place, so that's 2. And then for 3, it'll be a 1 in the 2's place, a 1 in the 1's place. And then we get to 4, so a 1, 0, 0. Then we get to 5. Then we go to 6. Then 7. And it continues going up like this. So for 8, 1, 0, 0, 0. And you might practice counting like that on a piece of paper or on a whiteboard that you have available, so you understand how it works. After 8, this would be 9. Then 10. Then 11. Then 12. 13. 14. And 15. So counting with binary. Each place value is base 2, so you move over into the other place values a lot quicker than you would in the denary or the decimal numbers. In hexadecimal, or base 16, you could think of this as the ones place, 16th place, 256th place, or 4096th place. You can also think of it as 16th to the first power, 16 to the second, 16 to the third power. With hex, because we don't have a single digit that represents 10 in our decimal or base 10, we have 2 digits, 1 and 0 represents 10. We change that to an A because we want a single digit that represents 10. So in hex, it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, basically. Okay, so counting with hex, we are going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When we get to 15, next one comes over to the 16th place. Then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And again, another digit in the 16th place, and we go back to 0, 1, 2. Continue on like that. So you can kind of see it's a base 16. It goes up to 15, but we're starting at 0. That's why it's a base 16 number system. And if we were counting with the hex digits, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Sixteen, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So hex 1A is going to be in decimal or denary equal to 16, because there's a 1 in the 16th place, and A, which is equal to 10. So that's going to be 26. Let's look at one more of those before we go on to converting. So if we had a 2 in the 16th place and a 6 in the 1's place, so the hex is 2, 6, and we pronounce that 2, 6. The 2 would be equal to 32 because it's 16 plus 16, so it would be 32, and then we'd add the 1's place, which the value is 6, so 32 plus 6 is going to be equal to 38. Okay, let's go into conversions. Okay, let's try a denary to hex conversion. So we'll try the number 45. One way to do it is to look at the different place values of the hex. So 256 does not go into 45. 16 does go into 45 2 times. And another way to look at it is 45 divided by 16 is going to be equal to 2, with the remainder 13. And so the first, the digit in the 16th place is going to be 2, and the digit in the 1's place is going to be the remainder, which is 13. So if you look at 13, the hex digit corresponding to decimal 13 is going to be D. So for this one, for 45, decimal converted into hex, it's going to be hex 2D. Let's try another one. Alright, let's try converting a larger number So denary or decimal 786. Now 4096 is not going to fit into 786, I can tell that, but 256 will. So you have to figure out how many times is 256 going to fit into 786. It's going to be 3 times, because 3 times 256 is going to be equal to 768. So you can see 768 is smaller than 786, so that will fit inside. So to figure out what's left over, I'm going to take 786, the number we're converting, and I'm going to subtract what I took out of it, which is 256. So you know there's going to be a 3 in this column right here. So 786 minus what we took out, which is 768, and that's going to be equal to 18. So then we have to check, does 16 go into 18, this number that we have left over? Yes, it does. It goes in 1 time. And what is left over? 2. And so the 2 comes right here. So 786 decimal or denary number converted into hex is going to be hex 312. Another way to convert denary 786 into hex is to just keep dividing by 16, and then the remainders are going to be equal to the first digit in the ones place, then the digit in the 16th place, and then the digits, so on like that. So let me show you how that one works. So 786 divided by 16. On my calculator, that is going to be equal to 49.125. Now, I don't want this decimal point, I want the remainder. So I am going to take this 0.125, I'm going to multiply that by 16 so that I can get the remainder. And the remainder is going to be equal to 2. So basically, 786 divided by 16 is equal to 49, remainder 2. So this 2 right here is going to be my first digit. Next up, I'm going to take the 49, and I'm going to divide by 16. So 49 divided by 16 is going to give me 3.0625. Again, I want the remainder here, so I'm going to take the 0.0625, multiply that by 16. That is going to give me 1. And the 3, 16, 3 can't be divided by 16, isn't going to fit into 3 again, so the 3 comes down as the last digit. So the hex number would be 3 in the 256th place, 1 in the 16th place, and 2 in the 1's place. So 786 denary or decimal into hex is hex 312. So we're getting the same answer, but we're doing it a slightly different way. Let me show you that one more time. Alright, let's do denary to hex again. So we will try 491. We'll convert that into hex. So the first thing I'm going to do is I'm going to divide it by 16. That is going to give me 30.6875. Now, in order to get the remainder, I'm going to take that 0.6875 and I'm going to multiply it by 16. That is going to give be 11. And then I'll take the 30 and I'll divide that by 16. That is going to be equal to 1.875. Or you could think about it as 16 is going to go into 30 once, and it's going to be the remainder is going to be 14. Okay, so the first remainder, 11, that's going to be our digit in the ones place. So that's going to be B. The next remainder is 14, and then remember we had that 1 left over. So 14 in the 16th place. And remember, if we look down at this chart down here, 14 is going to be equal to E. So we put an E in there. And then the 1 is going to be a 1. So 491 decimal or denary, convert it into hex, is going to be 1 E B. Alright, let's try going from hex to binary. So hex to B. What I'm going to do is I'm going to break that up into 2 nibbles. So I like to put the stabilizers above. 1, 2, 4, 8. 1, 2, 4, 8. And so I have my 2 nibbles, 4 binary digits each. This B is going to come over here, and I'm going to do the 2 right here. So let's start with the B. You can see down here that B is going to have a value of 11. So to mark out 11, we got 8, 9, 10, 11. This is going to be a 0. And to mark out a 2, we got the 2 here, 0, 0, 0. So 2B hex into binary 2 nibbles is going to be 0, 0, 1, 0, 1, 0, 1, 1. Alright, let's try another hex to binary conversion. So we'll do hex 7D. First thing I'm going to do is I'm going to split that up into 2 nibbles. So 4 bytes each, and I like to put the stabilizers on top of those. So I go 1, 2, 4, 8, 1, 2, 4, 8. And the D is going to come over here, and the 7 is going to go right down there. So for my first binary digit for D, I come down here, I check out D. D is going to be 13. So I need the 8, I need the 4, 12, and then 1 more to 13. This 2 will be a 0. And then 7 is going to come down here, so that's going to be 4, 2, and 1, and this will be a 0. So 7D hex into binary is going to be 0, 1, 1, 1, 1, 1, 0, 1. 2 different nibbles. Alright, let's do some more conversions. Alright, let's convert a hex to denary. So a hex that we will convert will be E9. And I'll show you a couple different ways to convert this. So E9, one way to think about it is with these place values down here. These are the place values for the hexadecimal. 1 this is 16 to the first power, 16 to the second power, and 16 to the third power. So if we look at E9, E is going to be in this place value, and 9 is going to be in this place value. So what that means is, let me get another pen. E is going to be multiplied by 16. And if we come down here, we can see E is 14, so it's actually going to be 14 times 16. And that is going to be 224. Oh, I can put it down here as well, 224, 14 times 16. And then the 9. You could think about the 9 as like times 16 to the 0 power. It would basically, you're just using this 9. So it would be 224 plus 9. And that's going to take you to 233. So our answer here is 233. E9 in hex is equal to 233 in denary or decimal. And that's using the place values. Let's do it one more time with a little trick where we move it into binary first. Let me erase all of this. So if we're going to move E9 into binary, we'd break it up into 2 nibbles. 1, 2, 4, 8. And 1, 2, 4, 8. 9 is going to be 8, 9, 10. Oops. Sorry about that. 8 is going to be, 9 is going to be equal to 8 and 1, 0, 0. And E is going to be 14. So that's going to be 8, 9, 10, 11, 12, 13, 14, and this is a 0. So we have our 2 binary, but like I said, we want to go all the way to denary. So what I like to do is I like to add a 6 over here. So instead of being 1 now, that place value is 16, because I'm going up in the place values of binary. We're going 1, 2, 4, 8, then 16, then 32, then 64, then 128. So again, we're just going up in binary place values. This is 2 to the first, 2 to the second, 2 to the third. Maybe I should write that up. 2 to the first, 2 to the second, 2 to the third power. Then we're going 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, and 2 to the seventh power. And that's going to be, I wrote 8 twice. 2 to the sixth power is going to be 128. So I just added a 1, 2 in front of the 8. Okay. Now that we have those stabilizers up there, we can see that this is going to be, this 1 in this binary digit right here, this 1 is going to be equal to 128. This is going to be equal to 64, so 128 plus 64 plus 32. And then there's no 16s here. This is a 0. So we come over here, plus 8 and plus 1. And when we add up all those together, again, we are going to get 233. So E9 hex is equal to 233 in decimal or denary. Alright, let's do one more. Alright, let's try hex 4C. And we're going to convert that. And again, we're going to use the method where we convert it into binary first and then go to denary or decimal. So for C, I'm going to put the stabilizers on top, 1, 2, 4, 8, and 1, 2, 4, 8. And I'm going to convert the C over here and the 4 right here. So if I look down at my table, C is equal to 12. So I'll have a 1 for 8, 1 for 4, 0, 0. And 4 is going to be just 4, 0, 0, 0. But we want to go all the way to denary. So I'm just going to go up in place values for binary. So 1, 2, 4, 8. This is I'm going to change this 1 into 16. I'm going to change this 2 into 32. I'm going to change this 4 into 64. And I'm going to change the 8 into 128. Okay? So then when we look at this, this is going to be 64, because there's a 1 right here. There is no 128. There's no 32. There's no 16. There is an 8. There is a 4. So you can do plus 8 plus 4. And this is going to be equal to 76. So in our conversion, 4C hex is going to be equal to 76 in denary or decimal.